Now let's consider the same sphere. This integral won't necessarily hold and this integral won't necessarily hold, but we're going to have the same limits on the integral because it's the same sphere. We're going to assume a mass density function, delta of x, y, z, just equal to 1 plus y. With this density function, the mass of your typical volume increment and the volume increment now will involve an xi, yj, and a zk. That volume increment will then contain the point xi, yj, zk star on each is density times volume equals what? The density will be evaluated at our sample point, xi star, yj star, zk star, and the volume will simply be delta x by delta y by delta z. And following the order in which the increments appear in the integral, we'll go ahead and say this is delta z, delta y, delta x. We could write the sum that we say approaches as delta x, delta y, and delta z go to 0, and I'm not going to write down that specific either. Is going to approach the triple integral over this region of your density function, which is simply 1 plus y times dz, dy, dx, and between the same limits as before, 0 to 1 here, 0 to the square root of 1 minus x squared here, and 1 minus the square root of 1 minus x squared minus y squared, to 1 plus the square root of 1, make that a 1, minus x squared minus y squared. Eventually I'll learn to leave myself enough room, but hopefully that's legible enough. Now let's proceed to perform this integral, which again will be the mass of the sphere given the density function 1 plus y. Now that means as we move from 0 to 1 on the y-axis, the density is going to move from 1 to 2. Rather, the density will change from 1 to 2. Okay. Our antiderivative of 1 plus y with respect to z, well, the 1 plus y is constant with respect to z. So we can first say that this is going to be the integral from 0 to 1, from 0 to the square root of 1 minus x squared, and then I'm going to factor out the 1 plus y before writing the z integral, which will be 1 minus the square root of, let's stop and make sure we get the 1 in here, 1 minus x squared minus y squared, to 1 plus the square root of 1 minus x squared minus y squared. Now we have dz, dy, dx. Our first integral is just going to be the z integral, and it's going to work out exactly as it did before because our z function doesn't have any dependence. Our z integral is just a constant, doesn't have any specific dependence on z. So that we end up with the integral from 0 to 1 of the integral from 0 to square root of 1 minus x squared And since the z integral is the same as in the last example, I'm just going to write down the result. We're going to have z evaluated between these two limits, and that's just simply going to give us 2 times the square root of 1 minus x squared minus y squared, and then we have the y and the x integrals. I'm sorry I left off my 1 plus y here. I was all excited about having enough room between where I was writing and the edge of the page that I went and spread everything out. Now I'm going to have to compress it as well as admit to an error. Okay, so I have now this 1 plus y dy dx. Factoring out the 2 and writing this in a slightly more standard form, then we have 2 times the integral from 0 to 1 times the integral from 0 to the square root of 1 minus x squared times 1 plus y square root of 1 minus x squared minus y squared dy dx. Now, how are we going to integrate this expression with respect to y? If we distribute the multiplication, we'll have 1 times the square root of 1 minus x squared minus y squared, and we know how to integrate just that term. Y times the square root of 1 minus x squared minus y squared is actually even easier to integrate. We'd simply let u equal 1 minus x squared minus y squared, so that our du will be negative y squared dy, and we'll have a y dy, and it's all going to work out. So let's begin that process. I'm going to break this into 2 integrals now. According to what I just said, we have 2 times the integral from 0 to 1 times the integral from 0 to the square root of 1 minus x squared of 1 times the square root, and that's just going to be the integral of square root of 1 minus x squared minus y squared dy dx, plus very similar integral, well, we have a 2 out here that I almost forgot, 0 to 1, 0 to the square root of 1 minus x squared, y times the square root of 1 minus x squared minus y squared dy dx. We'll integrate these with substitutions that I'm going to write on this page, and then we're going to continue on another page. But just to indicate what the substitutions would be, we're going to let, in this case, let y equal the square root of 1 minus x squared cosine theta, etc. Exactly the same process we've used a couple of times, but now we've got this integral here, and in this case we're simply going to let u equal 1 minus x squared minus y squared, so that du is negative 2y dy, and the y dy that we have here is then negative 1/2 of a du. So we're going to just have the integral of negative 1/2 du between these limits on y. We'll complete that integral on another clip.